Dear cadets, Assalamu alaikum and a very good morning. It's Ghulam Izdan, Associate Professor of Statistics from Borishal Cadet College, to have a delivery on online class with you. You know your normal classes are disrupted due to the worldwide crisis COVID-19. But we can't sit idle, indicating that problems. That is why we are arranged these online classes so that your learning process may continue at a satisfactory level. Today, I have designed my class on the topic binomial distribution. Okay, boys, let's start from learning outcomes. After this lesson, cadets will be able to solve mathematical problems. Dear cadets, previous class we have solved the problem 1. Now we solve the problem 2. Problem 2 is a pair coin tossed 5 times. Find the probability of getting question A exactly 2 heads. Question B, no heads. Dear cadets, now the solution of the problem. Let x be a random variable denoting the number of heads, that is the value of x equal to 0, 1, 2, 3, 4 and 5. Dear cadets, now binomial variate, that is the number of trial n equal to 5 and the probability of success p equal to 0.5 and the probability of failure q equal to 0.5. Dear cadets, we know the probability function of binomial distribution f of x equal to p of ncx q to the power x q to the power n minus x. Now, putting the value of n, p and q, we get the probability function of binomial distribution f of x equal to 5cx (5cx) 1 by 2 to the power x and 1 by 2 whole to the power 5 minus x, where x equal to 0, 1, 2, 3, 4, and 5. Dear cadets, now the question A, probability of exactly two heads, that is the value of x equal to 2. Now the probability of x equal to 2 equal to 5c2 into 1 by to the power 2 into 1 by 2 to the power 5 minus 2. Finally, we get the probability of exactly two heads equal to 0.3125. Now the question number B, probability of no head, that is the value of x equal to 0. Now putting the value of x equal to 0 in binomial distribution, we get 5c2 into half to the power 0 into half to the power 5 minus 0, because here x equal to 0. Finally, we get the value probability of 0 head equal to 0.03125. Dear cadets, the problem number 3. The probability that a patient covers from a COVID-19 is 0.6. If 5 people are known to have contracted this disease, what is the probability that Roman 1 exactly 3 survive, Roman 2 at least 2 survive, Roman 3 at most 2 survive, and finally Roman 4 none survive. Dear cadets, now the solution. Let here x is a random variable denoting the number of patients recovering from COVID-19. Here, the total number of patients n equal to 5, and probability of recovering p equal to 0.6. So probability of dying q equal to 0.4. Now, from the given information, we can easily say that x follows binomial distribution, because here the number of trial n equal to 5, that is n less than 30, and the probability of success is not very small. So the problem follows binomial distribution. and the probability function will be f of x equal to ncx q to the power x q to the power n minus x, where n equal to number of trial, p equal to number of success, q equal to number of failure, and x is the number of success. Here x equal to 0 on to up to n, where n less than 30. Now putting the value of n, p and q, we get ncx into 0.6 whole to the power x into 0.4 whole to the power 5 minus x, where x equal to 0 on 2, 3, 4 and 5. Now the question Roman on. The probability of exactly 3 patients will survive. That is, here the value of x equal to 3. So we can write the probability function of binomial distribution f of x equal to 3 equal to 5 C3 into 0.6 whole to the power 3 into 0.4 whole to the power 5 minus 3. Here n equal to 5, probability of success p equal to 0.5 and the probability of failure q equal to 0.4. Finally, after calculating, we get the probability p of x equal to 3 equal to 0.35. Dear cadets, now the question Roman 2. The probability of at least 2 patients will survive. That is, f of x greater than equal to 0. Its mean f of x greater than equal to f of x equal to 2 plus f of x equal to 3 plus f of x equal to 4 plus f of x equal to 5. We know that the total probability equal to 1. So we can easily write f of x greater than equal to 1 minus p of x equal to 0 minus f of x equal to 1. Now, putting the value of n, p and q, we get f of x greater than equal to 2 equal to 1 minus 5c0 into 0.6 whole to the power 0 into 0.4 whole to the power 5 minus 0 minus 5c1 into 0.6 whole to the power 1 into 0.4 whole to the power 5 minus 1. After calculation, we get f of x greater than equal to 2 equal to 1 minus 0.01024 minus 0.0768. Finally, we get the probability f of x greater than equal to 2 equal to 0.91296, that is 0.9 on. Dear cadets, the question Roman 3, the probability of at most 2 patients will survive, that is f of x less than equal to 2 equal to f of x equal to 0 plus f of x equal to 1 plus f of x equal to 2. Here the maximum value of x equal to 2. We know the probability function of binomial distribution equal to ncx e to the power x e to the power n minus x. Now, putting the value of n, p, q, and x, we can find p of x equal to 0 equal to 0.01024 and f of x equal to 1 equal to 0.0768 and f of x equal to 2, that is 5c2 into 0.6 whole to the power 2 into 0.4 whole to the power 5 minus 2. Now, finally, we get f of x less than equal to 2 equal to 0.01024 plus 0.0768 plus 0.2304. Finally, we get f of x less than equal to 2 equal to 0.32. Dear cadets, the next question, that is Roman 5, none survive, that is f of x equal to 0. Now, we know the probability function of binomial distribution f of x equal to ncx e to the power x q to the power n minus x. Now, putting the value of x equal to 0, n equal to 5, p equal to 0.6, and q equal to 0.4. Finally, we get f of x equal to 0 equal to 0.0124, that is 0.01. Dear cadets, now the problem 4. Out of 800 families with 5 children is how many families would you expect to have? Roman 1, 3 boys. Roman 2, 5 girls. Roman 3, either 2 or 3 boys. Here, we have to assume equal probabilities for boys and girls. That creates now the solution. Here we let X is a random variable denoting the number of boys. And the number of children in each family n equal to 5. Total number of families capital N equal to 800. And the probability of boys P of x equal to 0.5. And the probability of girls Q of x equal to 0.5. From the given information, we can easily say that X follows binomial distribution because here the number of trial n equal to 5, that is n less than 30. And the probability of success P is not very small. So it follows binomial distribution. And the binomial function will be f of x equal to ncx q to the power x q to the power n minus x. Here x equal to 0, 1, 2 up to n, where n less than 30. Now putting the value of n equal to 5 and probability of success p equal to 0.5 and the probability of failure q equal to 0.5, we get f of x equal to 5cx into 0.5 whole to the power x into 0.5 whole to the power 5 minus x, where x equal to 0, 1, 2, 3, 4, and 5. Dear cadets, now the question Roman 1. The probability of 3 boys, that is, here the value of x equal to 3. So the probability function of binomial distribution f of x equal to 3 equal to 5c3 into 0.5 to the power 3 into 0.5 to the power 5 minus 3. That is f of x equal to 3 equal to 0.3125. So the expected number of families having 3 boys equal to n into f of x equal to 3, where x equal to 800 and f of x equal to 3, that is 0.3125. Finally, we get 250. So the number of families having 3 boys equal to 250. Dear cadets, the question Roman 2. The probability of 5 girls, that is no boys, all are girls. So we can write f of x equal to 0. That is 5c0 into 0.5 whole to the power 0 into 0.5 whole to the power 5 minus 0. Finally, we get the value 0.03 on to 5. So the expected number of families having 5 girls equal to n into f of x equal to 3. Here the value of n equal to 800 and f of x equal to 0 equal to 0.03 on to 5. Finally, we get 25. That is the number of families having 3 girls equal to 25. The next question, the probability of either 2 or 3 boys. That is f of x equal to 2 or x equal to 3 equal to f of x equal to 2 plus f of x equal to 3. Now, putting the value of n equal to 5, p equal to 0.5 and q equal to 0.5, we get f of x equal to 2 or x equal to 3 equal to 5c2 into 0.5 whole to the power 2 into 0.5 whole to the power 5 minus 2 plus 5c2 into 0.5 whole to the power 3 into 0.5 whole to the power 5 minus 3. Finally, we get 0.3125 plus 0.3125, that is f of x equal to 2 or x equal to 3 equal to 0.625. So the expected number of families having either 2 or 3 boys equal to n into p of x equal to 2 or x equal to 3, here n equal to 800. So finally, we get the value equal to 500. That is, number of families having either 2 or 3 boys equal to 500. Dear cadets, here are some possible questions of binomial distribution. Roman 1, p of x equal to 0 or p of x less than 1. Roman 2, probability of getting exactly 1 or p of x equal to 1. Roman 3, probability of getting at least 1 or not less than or 1 or probability of x greater than 1. Roman 4, the probability of getting at best or at most 2 or not more than 2. That is probability of x less than equal to 2. Roman 5, the probability of getting more than 2 or less than 4 or between 2 and 4 exclusive, or P of x greater than 2 less than 4, or P of x equal to 3. Roman 5, probability of getting between 2 or 4 inclusive, or probability of x greater than equal to 2 less than equal to 4. Roman 6, the probability of getting more than 2, or probability of x greater than 2. Finally, Roman 8, there is probability of getting less than 2, or probability of x less than 2. Dear cadets, now the uses or application of binomial distribution. Number 1, number of defective items in a randomly selected sample of less than 30 products. Number 2, the number of days increasing price index in sharing market in a randomly selected 15 days. Number 3, the number of correct answers in a 25 MCQ question test if a student answers all the questions randomly. Number 4, the number of workers suffer from occupational disease in a randomly selected sample of 10 workers. Number 5, number of successful hits in a target out of fixed number of hits. Finally, number 6, the number of customers buy a particular commodity. Dear cadets, then any question? Dear cadets, here is your homework. Question number 1, Roman 1, 3 coins is tossed simultaneously. Roman 2, 30% of the plate produced by a machine are defectives. These are being marketed by packeting 4 blades in each packet. The question 1, what is binomial experiment? Question 2, established the relation between mean and variance of binomial distribution. Question 3, find the number of defective packets of 3000 packets are placed 2 defective items of stem 2. And the question D, if X be the number of success of getting hits, then show that the binomial function of x equal to 3 of stem, that is Roman on, is p of x equal to 3 equal to 3c3 into p to the power 3 into q to the power 3. Dear cadets, okay, dear cadets, thank you for your sincere participation of my class. I think you will view it again at your own convenience. Another significant point, dear cadets, you must bear in your mind that you are now passing a very crucial moments. COVID-19 has made our life unstable. You should be serious enough to cope up this situation with much care and responsibility. Please don't go outside at any rate. Remain confined completely within your own residence. Enjoy the prolonged vacation and make your study regularly. Spend your pleasant moments with your parents, brothers, and sister at your own residence. Stay home and fine, dear cadets. Thank you very much.